Okay, I'm just going to read off the top of the sheet here. Follow along as I read. An atom is made up of protons and neutrons, which are in the nucleus, and electrons, which are in the electron cloud surrounding the atom. The atomic number equals the number of protons. The electrons is in a neutral atom equal to the number of protons. The mass number equals a sum of the protons and the neutrons, as you see in the example in the box at the top of the page. Charge indicates the number of electrons that have been gained or lost. A positive charge indicates the number of electrons, which are negative, lost. A negative charge indicates the number of electrons gained. This structure can be written as part of a chemical symbol, which is what this page is all about. With electrons, you have to remember something. Think opposites. Losers of electrons are positive. Gainers of electrons are negative. Are we ready? Are we ready? All right, let me find a good color here. Purple. Now, find magnesium on your periodic table. Tell you what, the bottom number, see the 12? That's the element number. So it is element number 12. Look for it. Let's realize something. I'll get you started on here. The atomic number of magnesium is 12. So go ahead and fill that in. We're going to go straight across. Look at your paper. You will see the mass number, I'll tell you what that means in just a moment, is 24, the top number. You see where it says charge. In your example box after the C you have a +4. That would be a charge of +4, meaning that element would have lost 4 electrons. Is there a charge listed for magnesium?
No.
No. So what will I put here?
0.
0. Now, how many protons? The atomic number, the bottom number, that is the number of protons that a magnesium atom has. So I will write what? 12. Good. Now, does everyone know how to count? Does everyone know how to subtract?
Yes.
You see the 24 and the 12? The 24 is the mass number, and as I read to you, and it's at the top of your page, the mass number means the total number of protons plus neutrons in the atom because they have almost exactly the same mass. And you see how the 24 is up top and the 12 is on bottom?
Yes.
Kind of already looks like a little kid elementary subtraction problem. So to get the neutrons, write this above the column. It's going to be the mass number minus the protons, or the top number minus the bottom number. So the number of neutrons, 24 minus 12, is 12. The electrons, if there's no charge, it's the same as the protons. So for electrons, I'm going to put 12. There you go, straight across the first element on the page, magnesium 2412. We read it as magnesium 24, and I'll explain that when the lesson about it comes up. But we say the element's name and then its mass number. This is something we call isotopic notation. Let's do the same with the potassium atom listed next. Its atomic number, which one, the 39 or the 19? 19. And mass will always be on top in this notation and will always be larger. The atomic number will always go on the bottom and will always be the smaller number. Every time, no exceptions, except maybe for hydrogen where they could be the same number. Mass number is, that means there are 19 protons plus some neutrons to make a mass of 39. What's the charge given? 0. How many protons? 19. It is the atomic number. How many neutrons? How'd you get 20?
You subtract.
Subtract. That is correct. Subtract them.
Yes.
All right, so
Do it.
I erased that in case you did not notice. It's always the mass minus the atomic, or the number of protons. In this case, we get 20. The electrons, same as protons, so 19. All right, I'll pause the recording, give you a chance to catch up. Oh, now we get to look at another one that has a charge this time. Since we already see the +1, let's put the charge in there. Charge is
1.
Positive 1. Yes, the positive means something, so we're going to actually put the plus sign. All right, think in terms of pre-algebra. When we subtract a negative, minus negative always means positive. Plus negative always means negative. Remember that as we go through some of these. What is the atomic number of sodium? 11. What is the mass number given? 23. See, the mass number may change. As you'll see if you look down the page, some of the same symbols have different mass numbers for a reason. The number of protons will never change. How many for sodium? Atomic number is
11.
So protons is 11. That will never change. These two are always going to match. Every time I'm trying to put a check mark there. Neutrons, we still subtract. 23 minus 11. 12. Okay, now go back to what I said about pre-algebra a moment ago. A neutral sodium atom will start with 11 electrons because that's the atomic number. It means protons, but electrons always match. To get a positive charge, did this sodium atom gain or lose an electron?
Lost.
It lost how many? We're told 1. So this sodium atom lost a negative 1, didn't it? It started with 11, lost 1, has how many? 10. I might have said something a little incorrectly. Oh well, we see a mistake. What do? Fix it. Since this has a positive 1 charge, that means it lost an electron. That means this atom has 11 protons still, but now only 10 electrons because it lost 1. What is positive 11 and negative 10? Positive 1. Just like in math, right? Right? Okay. All right, we still have some time. Fluorine is negative 1. Hey, that's the charge. I'll go ahead and put that there. Atomic number of fluorine? 9. Do you notice that's element number 9 also? The periodic table is listed by order of atomic number. What's the mass number? 19. Now, I'll explain to you another time why you'll see decimals for the mass in the book and on the wall. Right now, just trust me, put 19. So I fix that. Protons is the same as atomic because the definition of atomic number is the number of protons in the atom's nucleus. Neutrons, we still do what? Subtract. 19 minus 9, 10. All right, this has a negative 1 charge. Did this atom gain or lose? It gained. Gainers are negative. Think algebra. If it had 9 to start with and gained 1, then it has 10. Simple enough? Okay, I'm going to pause the recording, give you a chance to try the next line, aluminum 27 with a positive 3. Of course, watching the video doesn't look like I paused, but I did. And there you see the answers for aluminum. Atomic 13, mass 27, charge positive 3, as we're told. Protons, same as atomic, 13. Neutrons, how to get to 14? Subtraction. Now, the thing is, aluminum started with 13 electrons. Positives happen because they lost negative charges. So this atom lost 3 electrons. So it's 10, just like in math. Well, think of it this way. When we have to beg for money, someone gives us something, we should feel kind of negative about ourselves, right? So if we gain by begging, we should feel negative about that. But if we help somebody by giving a few dollars away, what is that going to be? Should feel positive, right? So if we give away to help someone, we should feel positive about ourselves. But if we're the ones that need help, sometimes people feel negative when they have to gain by begging. And electrons, some of the atoms, they just beg for you to give them extra electrons. And other atoms can't wait to help somebody and give away their electrons. And all that's coming at a later time. Okay, hydrogen 1 with a 1 on bottom. Atomic number is 1. Mass number is, top number is 1. The charge given is 0. All right, you got this. Number of protons, 1. Number of neutrons, 1 minus 1 is 0. All right. Number of electrons, I don't see a charge. 1. All right. Give you a chance to try the magnesium given. Uh-oh. The bottom number is missing.
Oh, that means it's 0.
No, it doesn't mean it's 0. Find magnesium on your periodic table. That's what I want you to tell me. Where's magnesium? It is element number
12.
So you write the 12 there. It's a little sloppy on the screen, but it's supposed to say 12. Now, I'm going to give you a chance to do it. What? Did that on purpose to make sure that you know where to find it. Again, I'm going to pause while you try it. And there are the answers for magnesium 2+. During the pause, Josh, good question. 2+ is the same as +2. Now, I had to scrunch the +2 on the answer because of something on my iPad. It's a button that I didn't want to hit. That's okay. All right, before I clear this off to scroll up to do more, does anyone need to ask about anything you see up here?
No.
Yeah, Ivan?
I don't understand the neutrons and electrons.
Okay, pick one of the ones we've already done. The top one, magnesium. To get the neutrons, it is equal to the mass number minus the atomic number. That's supposed to be an A. So in this case, the mass number is 24 and the atomic number is 12. So the number of neutrons is 12. There are 12 protons in every magnesium atom. To get a mass of 24, there has to be 12 of something else, right? Those something else are the neutrons. So to get the number of neutrons, if you already know the mass, subtract mass minus atomic, and it works every single time. Does that answer your question? All right, he asked about the electrons. All right, look at, let me clear off the aluminum one and erase all this nonsense over here. Well, it's not really nonsense. Okay, aluminum started with 13 electrons, right? Now, the charge is +3, correct? Now remember that gainers are negative and losers are positive. So for this to be a positive charge, this had to have lost 3 of those electrons, right? 13 minus 3 is 10. Takes some getting used to, but once you get used to it, you'll be able to rip through this. All right, I'm going to clear all this off. Everybody ready? Okay, clearing off. This way I can scroll down and get some more up there. Where did we leave off? We're on the AG, right?
Yes. Yeah.
Okay.
Yes, sir.
I need to enlarge on mine. I need to enlarge on my screen. Okay, we did that magnesium +2, right?
Yes.
So silver, well, there's no number given, so we have to find it. Got just enough time to do 1 or 2 more. The atomic is silver 47. All right. The decimal, we're going to round off to the nearest whole number. So that will make the top number 108. And now we can do it. Once we know these two numbers, we can get everything else. The atomic number is 47. Mass number 108. Charge 0. Protons 47. Neutrons. Ooh, what do we do? Ivan, what do we do?
Oh.
What do we do, Ivan? Subtract is right. That is 61. Electrons. There's no charge. So it is 47. Well, you're not adding 0, you're not subtracting anything. So you're either adding or subtracting 0, I should say. All right, we got time to do one more. Which one?
Sulfur.
Sulfur, -2. Okay, no numbers given. Sulfur is element number 16. The mass, go ahead and round off.
32.
32. Again, I'll tell you later why it's a decimal. So, atomic is 16. What is that 32? Someone just said. Mass number at the top, 32. Charge?
-2.
Did it gain or lose?
Gain.
Gained. Gainers are negative. Protons? Neutrons?
16.
Electrons, you just correctly said it gained 2. Started with 16, now has 18. Guess what your homework is now? Finish that page, and we'll save the Bohr model page for tomorrow.